Hey y'all, guess what it is again. I'm just going to show you some various states of applying power to the MagAmp in the natural rest state. And instead of DC, I have made use of, at first I tried it with DC because I made this little power supply a long time ago. I got like a 22, 40, and 60 volt, something like that, tap on this transformer here, and I was rectifying it and putting into these heavy duty caps. So that wasn't working as well as I'd hoped, or having much effect. So I switched over to using AC. So I just tapped on the rectifier there, on the transformer side, obviously. But what it allows me to do is to try 3 different taps of the transformer. Oops. These three different taps. I can set it and you'll hear the difference in there. So right now, this is plugged in down there, but it's turned off. Note, it is turned off. Remember, okay, it's off. This one's the Variax on and up all the way, and we have 120 going through here. So it's vibrating in its low state. We're taking off of what I'm considering the output, which is the other side of each capacitor on the outer 2 legs. So this red and this green coming off of there. And those are being rectified and going to a cap, or this cap. And then there's a spark cap. Well, there's a little guy here that I'm using. And this is a reactance cap, so it's in parallel with the spark cap. And this is maximum gap. Oops. That's about 5.5 inches in between there, just so you know. So we're resting at 78 volts approximately, and I can short it out and it comes right back pretty quick. It's not major. It's enough to just barely arc as is and make a little bit of a arc come out of the coil there, but that's nothing, obviously. Okay, so this is the first state, the rest state, and you can hear the low 60 hertz come out of there and out of here. Both of these speakers are in parallel with each other, and they are on the center tap of the middle one and the end tap of this one down here. The center tap here and the center tap here is the variable 3 selection AC that I'm going to play with. So right off the bat, you can hear harmonics coming out in the 2 speakers as I turn this, and it's not even turned on, right? So I'm varying the tap on the secondary and to tune it with the other wall over here. But so that's only energy coming this way, obviously out of the back of the MagAmp. There's no pushing back yet. Now I'm going to turn this all the way down and kickstart the reaction. So this is stage 2, where we will trigger the the 22 volt secondary of this. This guy's getting pretty warm. 22 volt secondary, and it will kickstart the vibration reaction that's going on there, and we will see the saturation go up on this side. This is using the MagAmp in the opposite direction, where we'll increase the saturation on this side to allow current from the AC from this power supply to go to the speakers, but also counteract with the source frequency. So let me kick it in the high gear by tapping that. Now you see our voltage has already climbed to 190. That's rectified DC off of the outer outputs here. The spark gap's at 300 volt, so it's not going to fire until we get it up a little more. But now, notice what happened. This is still turned off. That's a neon bulb in that power switch. So there's enough voltage coming back from the center taps of that one and that one through that secondary out to the primary, and it's high enough to illuminate the bulb in the off state, which I don't understand. It must be I think it would have had to jump the switch to do that, but it must be before the switch. It looks like, I can't really tell from the, oops. It seems like it's lit up, both both terminals in there. But anyway, this is not showing any usage, obviously, because it's turned off. 0 amps, 0, 0, 0. Power factor. God damn it. Power factor 1. 0, 0, 0, 0. Anyway. So you see now, even in the second stage, without this being turned on, I can regulate the transformer and change the impedance load on this side of the saturation wall. And I don't know if you can hear it, but there are harmonics that are coming out. The lower the voltage tap on the transformer, the higher the harmonic. So here's a low one, or I'm sorry, here's a high one, and then there's a middle one. And now you can hear actually this one's a little bit above. So anyway, it's interesting how that affects it. So you see we're up to 190 volts. That's with it all the way up. The higher the voltage on here, the lower the amount I can get rectified. So when I turn it down, it starts to climb. So anyway, now that we have the reaction going, and we have this side vibrating with the source, now we're going to introduce a disturbance into this side by turning on the AC here and pump like 22 volts AC into these transformers, which I'm hoping is 180 degrees off phase, but I haven't been able to determine that yet. So here we go. So now saturation is much more. There's much more power output to be able to go through there to power these speakers. Voltage hasn't changed here until we get to the point where we go to the second tap on the transformer. Wait a minute. Hold on. It doesn't like me now. What am I doing wrong? There it is. I don't know. It's weird. But now we got enough to fire the spark gap. And looky there, 5.5 inches, remember? So now, I'm going to turn the other side up a notch and to full power. That's higher voltage, so it likes it right in the middle the best, the highest frequency. Let me go back to the spark gap real quick. Anyway, sometimes the arcing makes, the high voltage arcing makes the stage 1 resonance fall out and it kills the whole reaction. So it's a delicate tuning with what you're trying to do with this rectified energy coming off of here. You can throw the vibration reaction off by misusing the power here. So perhaps a properly timed connection to that capacitor would allow it to be used at peak cycle times per se and not disturb the reaction. If it arcs when it's at full voltage, it's much easier to sustain the reaction because there's so much more energy being used in there that there's enough ringing left going on that the reaction keeps starting. So it seems like it runs in a constant state of trying to, like a misfiring engine almost. It would, it would trigger, and then you would have a dampened kind of a bounce back and forth. You can almost visualize it by listening to it. That's why I recommend listening to your electricity. Listening to your electricity, to your circuits, because how else could you have determined this reflection and saturation oscillation would be occurring, really, with, and how it interacts with changes, unless you could somehow perceive it, and if not visibly, then audibly. If not visibly, then audibly. Anyway. I've been having arcs now. This is like way over current and over voltage for this thing. It needs to be sitting in oil because the arcs are jumping all the way down here, and I think I mentioned that already. Where's this voltage coming from? 2 primary coils wired in series. It's a 240 volt transformer capability by using both in series. But I'm doing that, but I'm only putting 120 to it, which means that the voltage should be half out here. So 44 volts should effectively be 22, but when in reality what we're seeing without any reaction going on is upwards of 80 volts, as we saw in the rest state. Or that's not the rest state. Alright, I can kill it by taking the variac all the way down. Keep turning it off and on abruptly is enough of a spike to where it keeps it going most of the time. But anyway, at rest, we'll discharge, and 60 volts. 85 when I turn this knob all the way up to the, highest voltage, or tap, the highest voltage tap on there with the switch off. And then as soon as I start the reaction, the light comes on. We are feeding back into the same circuit that we're hooked to. Probably a good thing. Right? So I wonder, I'm curious, I thought maybe I would see some numbers come up there meaning power going this way. We'll see what happens. But resonant state 300 volts here. The spark gap should fire like randomly. It's supposed to be 300, but it's not. Oh fuck! It's not always 300. See if I can get something better behind that. Never trust that thing. Never trust it. Pretty wild. I guess that's it. This is a really cool circuit, let me tell you. I don't have it really drawn up. Turn that off. I haven't really drawn up more than that. This is the same as before. This is where the AC is coming in instead, though, and yeah, actually, well, it's pretty right, except for the spark gap that's driving the high voltage coil. So anyway, but just the spark itself, obviously, is enough to disturb the circuit. The high voltage coil adds an additional inductive dynamic to the circuit and allows us to get some different harmonics and pitches going that you can hear coming out of there. You know, I've heard probably 7 or 8 different pitches in a harmony, and I can physically tell, you know, I can audibly tell that they are third harmonic, major third, you know, in musical scale, major third, fifth, and sometimes what seems like a seventh, or I don't know if it would be a seventh or maybe a sixth or no, but it's not a great harmonic note. But what we have in this case is the harmonics are coming out, yes, but the harmonics are creating. I think the harmonics exist from the bass, from the left side of the amp, and then other harmonics are happening here, whether it's based on this or just because of this and the cores. Anyway, these other harmonics are happening here, and so we have, I think, 2 to 3 different frequencies on both sides, and maybe they're the same frequencies, or maybe they're just somehow different. They're just in some way different, but they are in harmony. And, you know, I can disturb it. I can make it in disharmony. I can messing with this diode here in series, and or switching these around. You know, I can get it to start misfiring like a blown spark plug or two, and those disturbances are reflected here because massive surge of voltage happens at this output stage here that we can rectify, and that gets our voltage way up there. So the more I can keep it running in the disharmonic, like misfire state, and it's like a rubber band flapping kind of a, you know, disharmonic, dampened off, timed vibration because of whatever source is pushing back is not doing so at the right time. I think this is pendulum style, you know, basic. It seems to me that we're moving an electrical distance of the wave nodal points, and we can induce tuned harmonic reflection at said distance, which is determined somehow proportional to saturation. Said harmonic can be moved, or said nodal point can be moved one way or the other because of the saturation density, perhaps, which leads to a more stiff vibration, or it's hard to say. But anyway, this oscillator works on the beat frequency principle, because these two frequencies that are disharmonic interfere and create a third frequency. So if there's 2 or 3 here and 2 or 3 here, and they're all perhaps interfering at somehow different or somehow semi-related states, they're each then perhaps creating their own third frequency. So when that happens is when what seems to be the nodal point being shifted to the center here, where perhaps the quarter wave tap point is the highest voltage, which explains why I'm getting significant more voltage out from this tap. You know, and then it's because it's to the point where it's enough to now start driving the circuit and filling up that 5 microfarad capacitor, and that one in series enough to spark that coil one hell of a jolt. You know, the original driver for that couldn't drive it that way. It would never, using the SCR method, it was the frequency would slow way down the higher the voltage you got. So it was, practically useless. I was hoping I'd be able to crank it all the way up to 20 kilohertz and get 200K out, and wouldn't that be handy? But needless to say, these means are out of reach, and we have to figure out different ways to achieve them. The MagAmp has very interesting qualities. This is only the output half. By the way, I forgot to draw the rest of the primaries. But this is a saturation wall, and we can control its density electrically. It's like a wall of rubber, and we can control the stiffness of the rubber and perhaps its reluctance and permeability state in our favor to either choke or release current flow through in this case, we consider this the output circuit. It kind of works in reverse in this orientation, but it is pretty neat. Need to figure out a way to make the volume go down on these speakers. I've tried resistors in line, it doesn't seem to help a lot, and I've tried capacitors in line, and yeah, that helps, but then I don't get to hear the harmonics, so I have to have them at full volume for, to be able to hear some of those other things coming out. But nonetheless, it's pretty cool. Thanks for watching.